In this question, we're going to study this polynomial of order 3, which we can write in general as ax cubed plus bx squared plus cx plus d, with a, b, c, and d real. We need to have this condition in our problem, because here we are interested in polynomials that have real coefficients. We want to show that b must have at least one real root. Okay, so that means if we have x cubed plus x squared plus x minus 1, this one must have a root. Okay, it must have a 0. That means when graphing this polynomial, it must cross the x-axis. Okay, so for our case here, we're gonna study this p of x depending on the value of a. Since the study is the same, we're gonna assume that a is bigger than 0. We don't want to make a equal 0, because if we do so, we are not gonna have a polynomial of order 3. So that's why we assume that it's bigger than 0. If it's less than 0, it's the same study. Okay, so now we're gonna treat this one as a function. So let f of x equals ax cubed plus bx squared plus cx plus d, and it's gonna be defined on R, or minus infinity plus infinity. Okay, clearly f is continuous everywhere on R. Okay, that's what we need to prove this one too, but it's clear. We are not going to prove it here. So now we can apply the intermediate value theorem. Okay, so we have the limit of f of x as x goes to infinity. It's plus infinity because a is positive. It's the limit is here. So since a is positive, we're gonna have this dominant factor. Now we have the limit of f of x as x goes to minus infinity. It's minus infinity. Okay, what does it mean here? It means, so when x is in infinity, so the graph must have done something like this. Okay, so according to the intermediate value theorem, our f is continuous. There must be some n here, okay, such that f and some n such f of this 0 here. So some n which is 0, such f of this, oh sorry, I said 0, so some alpha, such alpha is equal to n, but n is 0. Okay, our n is gonna keep going up and down until it's here where we have this 0. So that means f of alpha is 0. That means this is a root of the polynomial. Okay, because look here, we are in, when x is going to minus infinity, we're going to minus infinity. Okay, there is no other way to go to minus infinity except this way. And when x is bigger, we go to infinity, in this manner. Okay, because it's x cubed. Okay, so it must be something like this, depending on the x squared. Okay, so we are going to minus infinity, but here. Okay, so but in general, when we do this, we are going to minus infinity and plus infinity, and therefore we are crossing the x-axis at this point alpha, and therefore f of alpha is 0. That means p, which is f of x, has a root. Okay, and therefore according to the intermediate value theorem, we have f of alpha is 0.